Hello and welcome to this video on solving quadratic inequalities. And in particular we're going to look at how to solve this algebraically, but I will have some graphs in the background so that you can see visually what it is that takes place, and hopefully that'll improve your understanding. So a typical problem would look something like this, where on the left-hand side of the inequality you can see a quadratic, and the inequality, it won't matter which way that's facing too much in terms of how you solve it. But sometimes it will not be 0 that's on the right hand side, and you may have to do some rearrangement to get it that way. But once you have it in this format, the first thing that you want to do is to factorize the left hand side, and in these problems they will typically factorize. If we do that, we're going to end up with x plus 7 in one bracket and x minus 5 in the other as the factorized form for that quadratic. Now when you do factorize a quadratic, what you would know graphically, hopefully, is that you can find the roots. And the roots for this would be that x is negative 7 and that x is positive 5. They would be our two roots, because both of these would make this equal to 0. But since this is an inequality problem and we want this to be greater than 0, the answer is not going to be negative 7 or positive 5. The answers are going to be in the form of inequalities as well. So now what I've done is I've drawn this graphically using a computer program, and I've zoomed in to the particular parts of the graph where we can see those two roots. Now because we want this inequality on the left hand side to be greater than 0, what that means is that first of all we will want any value of x which is less than the negative 7. And if you substitute those values into the inequality on the left, you should get a value which is greater than 0. The main reason is because you're going to be multiplying two negatives. Similarly, on the right hand side, you're going to want any value of x which is greater than 5, because any value of x which is greater than 5 is also going to give you a positive number on that left hand side. So when it comes to writing your final answer, you have two possibilities. X is either less than negative 7 or x is going to be greater than 5. And so this is one type of inequality problem that you may come across. In this next problem, we still have an inequality where we've got the quadratic on the left, only this time it's less than or equal to 0. And again, we will factorize that quadratic, and then if I drew a graph, this is how that would look. And we can see the two roots are 7 and 2 from our graph. Now because we want this to be less than or equal to 0, rather than going outside of those roots and going beyond, we actually want to look at this region inside, because any value of x which is then between 2 and 7 will actually give us a value in the end that's negative. And you can test that out with a few values if you want to. When it comes to writing the final answer this time, you're going to actually write it as one inequality where you'll have x is less than or equal to 7, but also it needs to be greater than or equal to 2. And so the value of x can be within this region, whereas before it needed to be stated as two separate solutions. This question asks us to find the set of values for x for which both of these inequalities are true. And so what we'd do is we'd solve each inequality individually and then combine those results at the end. So the quadratic inequality will give us that x has to be less than 6 or greater than negative 4. It has to be between those two. And on the right hand side, if we go through solving that inequality just like we would an equation, we'll eventually get that x has to be less than or equal to 0.5. Now because it has to be true for both of these, we want to combine these inequalities. So whereas in the first inequality on the left we could have x is less than 6, the second inequality on the right tells us that x has to be less than or equal to 0.5. So combining those two and using set notation, we'd end up with a final answer that looks like this. Now, inequality problems don't always look like this. They are writing questions which will be presented a bit differently, but there isn't necessarily a need to have a graph, but it is useful to understand how the graph would work. They can sometimes be combined, so you just have to be prepared to use this under a variety of circumstances. Hopefully this video has been useful, and thank you very much for listening.